The second part of chapter 2 we're going to start right now. The nature of probability and statistics. The chapter in the book goes into definitions parts. They're a little bit lighter on this part, so this is a little bit deeper than what the book goes into. Again, as we go on, you'll see that some of the videos that we do go a little bit deeper. Some of them don't hit every topic in the book, and that's just fine. So this one, I'm talking about being a skeptic. All right. Now, statistics is a very powerful science. It gives us the ability to project from a sample to a population. It gives us the ability to summarize a group as a whole. But we have to be a little bit skeptical when we look at statistics. All right. Now, when I say skeptical, I don't mean be a conspiracy theorist and think everybody's trying to mislead you. I don't mean also that you should be a skeptic in the sense that you can dismiss anything you just don't like to hear. So that's not what I'm talking about. We have to deal with, oftentimes in statistics, tough subjects, things we don't want to hear, all that kind of good stuff. So this isn't a carte blanche tool to throw out everything we don't like. What I do mean by that is I mean that we should be able to recognize how statistics can be done wrong and how it can be misused. Now, sometimes these things happen on accident, sometimes it happens on purpose. And we'll give examples of these things. And again, oftentimes it's sort of a mix that, somebody may have repeated something that was misused on accident, or excuse me, so they repeat something thinking that it's true when in fact it's not. So again, when I say be a skeptic, I don't mean throw out everything or read into everything that we want. I'm saying recognize that studies can be done improperly, and studies, even if they're done properly, can be misused. So we're going to sort of categorize this in a few different ways. We're going to start with problems that can happen with the studies themselves. What I mean by this is the design of the studies. So the first term you see there is suspect samples. And basically, if a study is done and the sample does not represent the population well, then we say that the study has a suspect sample. All right. So, for instance, we talked the first part of chapter 1 about doing a convenience sample. If you did a convenience sample, you put a survey out on the internet, for instance, that would be a suspect sample of any population you choose. But also we saw that a cluster sample, if I'm trying to do a study on what people are buying at the grocery store, and I want to see what every human being is buying at the grocery store, but my sample only includes people from the age group from 20 to 30, then I'm missing out on a big chunk of my population. Now, I do want to mention that, and I'll mention this later again too, that notice we say the sample has to represent the population. That does not mean that the population can't be truncated. Your population doesn't always need to be every human being in the United States or every single individual that we can think of. All right, so your suspect samples is when your samples don't represent the population. The second problem that happens with studies is we have to be aware of the Hawthorne effect. Basically, this means that people behave differently when they know they're being studied. So if I go over to your house and I say, I am going to study what types of food you're eating, it turns out that you, subconsciously or consciously, would tend to eat better. And that's been known for a long time. Hawthorne's obviously the last name of a person that effect is named after. But the point is that if you have people watching you over your shoulder, or if you're just aware that they're going to be recording some data on you, then you might change your behavior a little bit. Okay? And so we have to do that. We have to try to, we have to try to like minimize that when we can. All right? Now, the two other problems with studies that I'm going to look at are confounding variables and lurking variables. Sometimes these are a little bit confusing because they're both variables that are somehow important to the study. So a confounding variable is one that influences the dependent variable but can't be separated from the independent. All right? Now, what does that mean? Let's take an example of something here. All right? So if I think about diet, oops, and having an effect on weight loss, all right? So we look at those two variables. We look at people's diet, and we look at how much they weigh sort of before and after we put them on such a diet, okay? Well, with diet, it turns out your activity levels are confounding. Well, let me put it this way. Your activity level is a confounding variable in that study, all right? Even if we include it, it's really hard to separate out activity level and diet. It turns out if I put you on a diet, a healthier diet, you tend to become more active. And vice versa. If I force you to be more active, you tend to eat a little better. All right. This is again just human nature on this stuff. But so diet and activity level are confounding activity level is confounding your diet. Again, it's putting it together. So even if I include it into a study, it's really, really hard to separate the two, all right, diet and activity level. Now, lurking variables, on the other hand, are variables that are left out of the study, but they affect the study, all right? So famous examples of this are, there was a study on smoking and it affects graduation rates. And it turned out that this study found that those who came from families whose parents smoked had lower graduation rates than those who came from families whose parents smoked, or did not, excuse me. So the non-smoking families had higher graduation rates, and the smoking families had lower graduation rates. Okay? Now, if you just looked at these two variables, what would happen? Well, if I just looked at these two variables, we're missing out a lot of factors that affect graduation rates and might be in some way, correlated with smoking. All right. So what are some lurking variables in this study? All right. Well, some lurking variables may include things like education level of parents. All right. Or things like ethnicity, or things like socioeconomic status. All right, things of this nature. All right, you can imagine that I could force somebody to smoke, right? And that probably wouldn't necessarily change their graduation rate, or excuse me, that probably wouldn't change their children's graduation rate. However, things like education, socioeconomic status, those things probably affect graduation rates. And also, people who smoke on average may have lower education levels and on average may be poor, all right, for whatever reasons. There's a lot of correlation there. Now, I'm not saying every smoker, I'm just saying the group as a whole. We'll talk about more of that in chapter 2, okay? So the point is, lurking variables are ones that affect graduation rates, but we did not include in our example or in our study, okay? There's lots of other examples that could be ripped out of the headlines today. Things like women getting paid less than men on average, right? Women paid less than men on average. All right. So what are some other variables that we might want to put on there rather than just gender and income? We would probably want to throw in like what types of jobs these groups are taking as a whole. We might want to throw in things like, well, how long have they worked there? And all of those things may factor into how much people get paid, okay? Same thing, education level, and you could go on and on and on and on and on. Now, what we're not saying is that there's no effect on with gender, but there are other variables to consider rather than just gender and income. All right. So hopefully that all makes sense. But again, if you're just looking at gender and income, you might be missing some significant variables. And why we would like to have a lot of variables is that so we can focus on how much of the difference actually comes from gender versus other things. Or again, these types of deals. So lots of examples out there that I could go to. I'm going to leave it at that. Confounding variables influence the dependent, but really can't be separated, like diet and exercise both affect an outcome of how much weight loss a person gets versus a lurking variable which affects the study but is left out. All right. Things like, again, was smoking, if I'm looking at smoking and graduation rates, you should probably look at some other variables. All right. So I do want to say that what I've done is I've just categorized 4 problems that can come up with studies. All right, this is how studies can be done, in like kind of in misleading ways or improper ways. But there are actually a lot of these things. There's whole books on problems that could have happened with studies. But these are probably 4 of the more common ones. And I would say when you're criticizing a study, the first thing you should look for is lurking variables. What are some variables that this person didn't consider and should have to get the complete picture of the story? Now, even if my study is done properly, when I represent the results of the study, I can do so in some problematic ways. So we're going to look at a few ways that I can represent data in ways that may be misleading or ambiguous or things of that nature. So the first is what's called ambiguous averages. If I said the average income in the United States is $45,000, and then somebody else came and said, well, the average income in the United States is actually $86,000. All right. We may be both telling in one sense, the truth, but we might be using different measurements to talk about averages. All right. Now, in this class, the word average is going to be reserved for mean. Okay. And we'll calculate means in chapter 2. But in other contexts, people will use like a median or a mode when they talk about averages. Most times in the United States, when you talk about income, you talk about the median income. And so people who are talking about it properly tend to say median income. But again, sometimes people will use the word average for median and mode instead of just for mean. The next problem with representing data is the idea of changing the subject. This is using different values for the same data. So one person will use one value and another person will use a completely different value. Now I have an example of this. It's a little bit old, but it's a pretty good one. I'm going to try to offend both sides of the political aisle today. And I'm going to go back a number of years to the 2012 election cycle. And we're going to look at ways that both President Obama and Governor Romney misled, I shouldn't say misled, but used changing the subjects to make their case sound a little bit better. Now, what I'm going to do is I'm just going to go to YouTube. I've just typed in Obama budget cuts visualization, and this video pops up. So you can see the URL right there to cite that. And what this YouTube personality did is they took a look at a press conference or in an article which said President Obama is going to order $100 million in budget cuts. And again, this was going into the 2012 election cycle. And so we read that headline, and that $100 million in budget cuts sounds like an enormous number, right? That is a gigantic number if you handed that to somebody in a briefcase. So what this YouTuber does is he says, well, what does that actually look like in context of the entire federal budget? And so what he does is he stacks up pennies about 5 deep, and then he lays them all out on the table. And to shorten the case, there's about 10,000 pennies here, And he's going to show how much of the federal budget is that $100 million.
Pennies on the right side of the blue line, if we can. Here's what President Obama says he's going to do. We'll just grab that penny there. Then we take 3/4 of our penny and we put it back on the budget. And the president's team is going to take 90 days to find some way to take this out of that. And suddenly, $100 million doesn't seem as big to me as when he said it in the press conference.
All right, so hopefully you see that a quarter of a penny out of about 10,000 pennies is that sort of $100 million out of the total federal budget. So that's a very small sliver of the federal budget when we're talking about it. So again, what we're talking about is changing the subject. So President Obama used a value that which he stated is 100 million. The YouTube personality, which is not me, but is some guy, I don't know who that person is, but used a visualization that showed that that is basically 1/4 of a penny out of about 10,000 pennies. All right, so different values for the same data. And notice that the idea you get, or at least the feelings that you get, seem very different. Okay, when it talks about 1/4 of a penny, that seems like a really small cut. When we talk about 100 million, that sounds like a much bigger cut. And so he used different values for the same data. Now we're going to go to the other side of the aisle in 2012. So President Obama ran in 2012. He was the Democratic candidate. The Republican candidate was Mitt Romney, Governor Mitt Romney. He's from Massachusetts. He's in a debate here. Again, this is on YouTube. You can cite that. You can look up that URL. And what he's going to do is he's going to describe how many people are off of health care in Massachusetts, the state that he ran, versus Texas, the state which this is Governor Rick Perry. He ran, he was in charge of Texas. I shouldn't say ran, but he was the governor of Texas. Mitt Romney was the governor of Massachusetts. So Mitt Romney, who was the Republican candidate in 2012, we're going to listen to him.
Speaking, we have less than 1% of our kids, they're uninsured. You have 1 million kids uninsured in Texas. 1 million kids.
All right. Hopefully you heard that. We're going to go back and listen to it just one more time.
We have less than 1% of our kids, they're uninsured. You have 1 million kids uninsured in Texas. 1 million kids.
All right. So if you were really savvy on that, you picked up what Governor Romney did. Now, by the way, was elected senator as well. So he's governor, senator. I don't know which one actually trumps in what you're supposed to call somebody who was governor and now senator. But anyways, he's senator at the time I'm making this video. So the point is, he used, when he was talking about Massachusetts, he was using a percentage value. He was using 1% of the kids from Massachusetts. Versus when he was talking about Texas, he used the value of over 1 million. All right. So for changing the subject, you know, we go 1% versus over 1 million. So again, think about what that sounds like. When you use a percentage, it's going to sound very small. Okay, when you use a raw number in that situation, it sounds fairly big. The same thing was true in the Obama budget cuts visualization example. When he used a big number, when he used the raw number, it sounded really big. When he used the percentage, it sounded really small. So using a percent versus a raw number is often a little bit of a trick. Now, again, both candidates were not, I shouldn't say candidates, both guys were not lying there. They were telling the truth, but they were telling the truth in a way that sounded best to the ear, okay? So you can listen to that. I've avoided the most recent elections, but those two are good examples. Those were such good examples that I like keeping those up, all right? By the way, oftentimes, like the percent will sound small and the raw number sounds big, but you can also do it in the exact reverse order. You can say something like a 300% increase. All right, a 300% increase, and that sounds like a gigantic percentage increase. Versus maybe it was only a you went from one person to four people, right? One person to four people would have been a 300% increase. So if I said this many people, there was a 300% increase of people who died from getting struck by lightning while on a golf course. And this golf course had one person struck by lightning last year and four people struck by lightning this year. That would be a 300% increase. Okay. And while that 300% increase sounds like a big percent, three people amongst the entire population of the United States is probably not a huge deal, right? It's probably not going to make the headlines of national news, all right? So sometimes the percent sounds small and the raw number sounds big. Other times the percent sounds big and the raw number sounds small, all right? The next problem with representing data is the problem of dealing with detached statistics. All right, this is where we give a statistic, but we really don't know our comparison. All right, so if I said this box of cereal has 1/3 less sugar, the immediate thing that happens in your head is, well, 1/3 less than what, right? What do we compare to? Or if I said, this person's height increased by 20%, you'd say, well, increased by 20% from what, right? That might be a gigantic jump. Over 2 years, that might not be a gigantic jump over 2 years. Who would know, right? So what are we comparing it to? All right. That is detached statistics when the comparison is not known. Implied connections, those are connections that may or may not be there, meaning that I say, well, since I became a math teacher at MMC, Mid-Michigan College, we got a new building. Now, clearly, probably me becoming the math teacher wasn't the catalyst for the college getting a new building. However, a lot of people do that. They'll say, well, one thing happened, then another, and they're implying that there's some connection between those two events. So again, after I got hired, we got a new building. Or you'll see politicians do this a lot. They will take credit for things that happened while in office. While I was president, the economy went up. Or while my opponent was president, the economy went down. Those types of implied connections. And whether it was actually based on the actions of the person, who knows? Maybe it was, maybe it isn't. But the point is that we're implying some connection. We're implying some sequence of events that happen. And then the last thing with representing data, there's a lot of ways to mislead with graphs. Now, to talk about each and every one of these would be not the right place here because we're going to talk about graphs in chapter 2. And so we're going to see a lot of different ways to mislead with graphs. And I'll get into, well, how do we mislead with bar graphs and line graphs and pie charts and all that kind of stuff. So we'll see more of that in chapter 2. But it suffices to say right now that if you have a graph that is not representing the data well, then obviously it could mislead. All right. So I wanted to briefly talk about problems that happen exclusively with polling. Polling has become a very prevalent thing in our society, all right? You see polls all the time, presidential approval polls, Congress approval polls. I brought some up the first part of chapter 1, the 1.1 materials. I brought up a couple of polls. And so I want to talk briefly about polling and bad things that can happen with polling. So first off, we can start off with faulty questions, questions that are biased, right? So you can think about some questions that you could bias, sorry. So questions like, ooh, that's bad. Do or don't you think our, I don't know, college is clean? Don't you think our college is clean? Things like that. It's kind of almost implied in the question that the college is clean, right? Or, changing the word clean to dirty would imply something like this. Or let's do another one. Another question that could be biased on a scale of 1 to 10, where 1 means a person is ugly and 10 means a person is very good looking. How many decimals how many decimals over 9 would you rank my looks? I can't type very well here today. Right? That's a really good question there, right? So on a scale of 1 to 10, based on looks, how many decimals over 9 would you rank my, right? Those types of things. Would you rank my looks, I said. There's probably a better way to say that. There we go. I'll just put it me that way. That's better. All right. So you can imagine that this question, although it's a little bit humorous, you'd get some really weird answers too, right? All of the answers would necessarily have to be between 9 and 10, right, on the scale, okay? Now, you don't have to be biased to that degree, all right? One of the things you learn as you get into this sort of bias questioning more and more is that just the way you phrase things or what you ask for will cause your listeners to react differently, okay? So for instance, let me ask basically the same question in a fairly I won't put any bad adjectives in there, but I'll talk about taxes. Should rich people pay, or I should say the richest people pay a higher percent on their taxes, income taxes. Now, I want you to just take a second and realize that should the richest people pay a higher percent on their income taxes? That's a yes/no question, all right? And it turns out most people, or a majority, maybe I should say that, will say yes, okay? Now, you can ask the exact same question, but instead of asking a yes/no question, you could ask a numerical question and ask what percent should the richest people pay on their income taxes. Now, the difference here is that I'm asking for a numerical value. And what happens here is that most people, or I should say the average, comes out to about 25%. Now, here's the trouble. That 25% is already lower than the percent that the richest people in America pay right now on their income taxes. Right now, the richest people in America pay, again, the percentage rate on their income taxes is about 39-ish%. Okay, that might have been changed. I always forget. I'm not in that bracket, so I don't pay that much attention to it, but it might have just got lowered to like 38%. But it's in the high 30s is the percentage rate. So when it says, yes, you should raise it to something that it's already lower than, then we have a dilemma here. So I got two different answers based on one where I asked a yes/no question versus one where I asked my respondents to give me a numerical value. And, you know, everybody knows this. This is why, oftentimes when you hear Republicans and Democrats debate, if they're Democrats are trying to raise taxes, they'll say things like, yeah, we should make the rich pay their fair share, or we should make the rich pay more. All right. That begs a yes/no question, right? Versus the Republicans may be more likely to talk about, well, it's already at almost 40%. How much do you want it to be raised to? Right? So begging the, hey, give me a percentage type answer. So the point is, questions can be biased, and if you're really clever, you can bias your question in really subtle ways. And so that's what we're talking about here. The other two things that I wanted to mention, one is I'm going to go to this third one first, is that things, not only can questions be biased in subtle ways, but you have to be really careful and clever about the way you order questions and conscious about ordering and questioner's appearance and things like that, okay? If I ask a bunch of questions about the economy and then ask how Congress is doing, you might get slightly different answers than if you ask a bunch of questions about polarization and then ask how Congress is doing. If I am going to give a survey and it's on whether or not marijuana should be legalized for recreational use, that was actually just voted on in Michigan, or recently as the time I'm making this video. But if I were to do that, let's say before the last vote, I may get different answers from some people based on my appearance. Now, again, there's going to be those people who are going to say yes no matter what you're dressed like. If you're dressed like a police officer and you go to their house and the police officer says, hey, what do you think about marijuana legalization? They're going to say it should be legalized. And there are people who, no matter what you dress like, are going to say, no, it's not, it shouldn't be legalized. You know, if you dress as the stereotypical hippie person, right? 60s type hippie person. And you go to their house and they're going to say no. But there are people in the middle who may change their mind. And a 5-point swing can be a huge swing on controversial topics. So you have to really pay attention to ordering and appearance and those types of ideas. Okay. Also, along with questioner's appearance, I should say, or I should mention that not only does appearance matter, but the way you sound matters. If you look and sound like somebody from my social group, I tend to be more likely to answer questions, and I tend to be more likely to answer questions truthfully. And on the opposite side, if you don't look and sound like somebody who may be in my social group, I would tend to avoid your questions or maybe not answer those as honestly. Okay, so this is why when people when polling places call, a lot of times they put people on who have the accent of the area that they're calling to. So if they're going to call in the deep south, they put somebody with that type of accent. If they call somebody from Minnesota, they might have people from Minnesota manning the phone lines. All right. Now, the last thing I want to mention is the middle bullet point there, that people can lie. All right. And whatever happens with polling, you always have to understand that polls which ask a question about what you are going to do are often a little bit suspect. All right. If I ask, hey, I want to create such and such a restaurant and bring it to Mount Pleasant, Michigan. Would you go to it? There might be a lot of people who say yes, but when it comes to the rubber meeting the road, don't actually go to the restaurant. For whatever purpose. And I'm not saying that people are trying to lie in a bad way, as in to deceive, but maybe they really believe when you ask them that they're going to go to your restaurant, but they just never get around to it and never actually do it. There's an old line, it's an economist saying, there's two economists that are walking by a car dealership, and one of them says, man, I'd really like that new car. And as they continue walking, the other one says, I guess not. And what that line means is that if you really wanted the car, you'd actually go do it. You would actually go buy it. So the purpose is sort of irrelevant what we're talking about, but people can tell you something that may not actually be true or may not actually come to fruition. Now, I wanted to also mention that there are a lot of things that aren't a problem that people often get upset about, or things like this. You can make your population a very specific group of people. All right. So if your population, if you want to do a study, you may want to make your population women between the ages of 18 and 25. And you might have really legitimate reasons for that. Maybe you're looking at, designing wedding dresses. And you say, well, when are women getting married? And it's in, 18 to 30 range. I don't know. I actually don't know the demographics of that one, but you can imagine that. Or maybe you want to look at girls between the ages of 6 and 12. And you'd say, well, why do you want to look at, toy preferences of girls between 6 and 12? Well, if you are Lego and you're trying to design the next Lego set for the Lego's Friends collection, which is their Lego series that's marketed towards young ladies or young girls, then you would probably be interested in those age groups and what girls of those ages, 7 to 12, really think. Okay, it's okay to do your study just on Caucasians, just on Asians, or just on name the group. That's fine. Okay, so you can make your population whatever you want, but once you set your population, that sample has to mimic it. It has to represent the thing you are looking for. The other thing that is not a problem is that in statistics, it is perfectly fine to look at differences between two groups of people or two groups of anything. All right. Some people really get, and for good reason, get upset when you look at differences of, average heights of males versus average heights of females, or average, males versus females. Think of Republicans versus Democrats. Think of white versus black versus Asian versus Hispanic. All this, all of these differences. And again, I'm not saying that, historically, sometimes that has been used for bad purposes, but statistically, it's perfectly fine to look at differences between two groups, two group averages. We'll talk more about how to interpret those differences in chapter 2, and we'll talk more about that all throughout the year. I'll try to use examples which sort of emphasize that these things aren't a problem and sort of show you why that is throughout the semester. Now, in a similar vein, I'm going to take that second point there. You can involve topics of religion and politics and not be controversial. Oftentimes, these are sort of hot button issues that we try to avoid talking about. But in statistics, you can definitely deal with these things and not be controversial. And again, I'll try to show you by example of what I mean by that. Okay. The other one thing I wanted to say, oftentimes people will get a little bit uneasy when our experimental and control groups don't match up in size. So if our experimental group is 100 people, but our control group is only 50 people, it turns out that's okay. So we don't have to have the same size groups because we're not comparing individual to individual. We're comparing group average to group average in statistics. And it turns out, again, statistics is really good to get trends and things like that. And that's what we're looking for. So we're going to, mimic this once we get into doing inferential statistics, primarily in chapter 12. I'll show you why numerically it's okay to have different size groups. All right. Two more things that are not a problem. You can generally trust data from government sources. And again, the word generally there doesn't mean that government sources always get it right or government-funded science experiments always do the right thing. But again, generally means most of the time we can trust data from government sources. Usually they're representing the raw data well. And again, we're going to look at a lot of that stuff throughout this year in your homework, you're going to see a lot of citations from government sources, the last census that was done, and so on and so forth. And the same is true with reputable polling places. They get paid money to do their job correctly. And so what they're not trying to, scam or pull the wool over people's eyes. They are trying to get as accurate as they can because that's where, their, how do I say, their bread and butter is doing things right. Okay. Again, it doesn't matter, doesn't mean that they always get things perfectly correct, but you can generally trust them to get their facts and figures straight. Okay. Again, generally speaking. Now, by the way, that doesn't mean they always get it right. We'll talk about how to read those polling stuff, because a lot of people think that when it's a 51% versus 49%, that means it's a done deal, slam dunk issue. That is not the case. A lot of times polling, the way it works is you have to think about it in terms of confidence intervals. So that 51% might be anywhere from 48 to 54%, if that makes sense. So you have to be a little bit wary of that. We'll see that when we get into confidence intervals in later chapters. All right. Now, the last thing I wanted to mention is that modern statistics is not done with a pen and pencil. Most of these ideas were actually developed in a time with pen, pencil, and paper. Okay, so that was all the ideas were developed then. But really, it wasn't until we had modern computing power that made statistics just boom. All right. And now we have statistics of all kinds of stuff, more stuff than you could probably possibly imagine, and stuff that you probably wouldn't want to imagine. So the idea is that now we have way more data than most of us can possibly, not any one of us, I should say, can possibly handle. We have an abundance of data. But this also presents an abundance of ways that we can manipulate, that if I'm a bad actor, I can change, I can mislead with that data. So we have to be very wary of the things that we're looking at. Okay. By the way, fun fact, nobody really knows Calvin Coolidge's approval rating, President Calvin Coolidge. And there was a reason for that. A lot of modern computing power didn't happen at the time. So if you look up Calvin Coolidge's approval rating, you probably could get some estimates, but there was no polls back then that happened. Whereas right now, the president's approval rating is done on a weekly basis with probably, I don't know, 10 different institutions, 10 different polling places doing approval almost every week, maybe every day. Some of those places, some of the bigger ones do it every day. So approval ratings for presidents are a fairly recent phenomenon, and it's kind of an interesting, again, modern computing made that available. That's the story. That's the interesting story. So what we're going to do is we're going to utilize that with your calculator, your TI-84, or if you have a TI-83, that'll work as well. And so we're going to take advantage of the TI-84 and the TI-83 to be able to actually do our calculations and do them in a way that sort of mimics how people actually deal with statistics now. Because writing down formulas and long drawn out formulas is not how people do it now. Okay. Now, that is the end of chapter 1. You should be able to do all of the, whoops, I apologize. I hit the wrong thing. So you should be able to do all of the homework, okay? So again, by Friday of week 2, make sure you have the chapter 1 homework completed. You get unlimited tries on that. So if you get a mistake, redo it, submit it again until you can get a perfect 10 out of 10. And then after you've done the homework, then start up on chapter 2 materials. And the chapter 2 materials, again, chapter 2 videos will be posted in unit 1, the section in unit 1. So hopefully that'll make sense. As always, if you do have any questions, let me know. Give me an email, give me a shout out. All right. Well, that's the end of chapter 1. Thanks for watching.